this video, I'm going to be showing you how to calculate the volume of a sphere. So a sphere is basically a 3D circle. It is a ball, and some objects that you can think of in real life that are actually spheres are a lot of sports balls. So your golf ball, softball, baseball, netball, soccer ball, they are all spheres. Another thing that's a sphere are the planets. So the planet that we live on Earth, that is a sphere. Okay, so a ball, a 3D circle. Here I've drawn a sphere and we're going to calculate the volume of it. So we're going to write down our formula. And the formula for the volume of a sphere is 4/3 pi r cubed. Okay. The only unknown that we have in this formula is the r. And we should know that r stands for radius, which means half the length between the halfway point of a circle to its edge. So you can see here that we are actually given a radius because the 22 millimeters is half from here to here. 22 mils isn't the whole way across. That is what we call our diameter. Half of it is our radius. So we can go ahead and say that 22 is our r. Now we're ready to substitute that number into our formula. Now remember, no gaps, imaginary time sign. So I'm going to write V equals 4/3 times pi times the radius, which is 22, cubed. Okay. And then we put it in the calculator exactly how we see it. So we've got fraction button, 4/3 times actual pi button times 22 cubed. See how it's exactly the same? We press equals, and we're rounding that to 2 decimal places, which is 44,602 plus 24. Now, because we want 2 decimal places, we have to look at the third number. Well, 8 is equal to or greater than 5. So that means that this number here will go up 1. So it'll change to 0.24, okay? And our units are millimeters cubed because we've calculated volume. Now, this is telling us that this sphere has this much space inside of it because that's what volume is. Now, if we wanted to find the volume of a hemisphere, which is half of a sphere, so literally if you cut this in half and got rid of the bottom half and just made it a 3D semicircle, half ball, it's actually a lot easier when you calculate the volume of a hemisphere compared to the total surface area. So when we deal with total surface area, and I'm backtracking a bit here, but when we deal with TSA, if we calculate it of a sphere and then a hemisphere, we have to obviously change the formula because all of a sudden from having a 3D ball, we now have an igloo. So a half 3D ball with a base, and this base adds on extra area to calculate with this curved area here. So this is total surface area. If we have a sphere, we just have our normal total surface area formula. And when we have a hemisphere, we have just the curved part plus the base. All right, so it's actually a little bit more difficult. And you'll remember that from the questions that you did previously with total surface area. With volume, it's much easier. If you want to find the volume of a hemisphere, all you need to do is take this formula and divide it by 2. That's it. You just have to halve it. Okay, that is all. No changing, no adding. You literally just take it and divide it by 2. In other words, halve it. So how do I do that? Well, I'll just make it clear that now I'm doing a hemisphere and write that in green. We'll highlight it in green. my green highlighter. All right, it again. So we need to halve this, which means dividing by 2. So halving is the same as dividing by 2. Halving is the same as dividing by 2. So we have 2 options. We can either do this, or we can do this. I'm going to let you guys think about which one looks less terrifying. And if you're agreeing with me, you'd say that this one looks less terrifying. I mean, if you look at this and you think, how am I meant to do a fraction divided by a number within a fraction and that's scaring you off, then fair enough. We can use this method instead. All right. I'll show you that we get the same answer with both anyway, but halving is the same as dividing by 2. So here I'm dividing by 2 and here I'm halving. So I'm timesing by a half. So the extras from this formula is this divide by 2 down here and this half over here. But dividing by 2 and halving is the same thing, because essentially you've got an imaginary 1 up here anyway, so it's actually 1 over 2. All right. Now, I'll show you this way first. To get an answer from this, you'd literally do 4/3 divided by 2 in your calculator. And the way you can do that is pressing your fraction button twice. So 1, 2. So you can see that this is the top fraction, and you do 4/3. So 4 over 3. Now we've got this part next, and then this part next. So the 2 needs to go down here. See how it's the same? 4/3 divided by 2, 4/3 divided by 2. And our answer is 2/3. So us halving the volume of a sphere formula is, oh, there we go, I've just made a mistake. 2/3 pi r cubed, because we need to get an answer by these numbers, and we get 2/3 pi r cubed. The reason why we don't touch the pi and the r cubed is because, yes, even though pi is technically a number, it's 3.14, blah, 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 but we're viewing it as a, let's say, pronumeral here, all right? Because it's not actually written as 3.14 as a number per se, we don't need to deal with it. Because 4/3 is written as an actual number, so fraction is still a number, we do the 4/3 divided by 2, and those 2 can just stay like that. Because you can't even do r cubed divided by 2. You don't know what r is. This is the formula. We're not using this example. Yeah, we know what r is in that example, but in general with the formula, we don't know what r is. It depends on the question. So you can't really touch that. So this is the answer for half of the volume of a sphere formula. Now I'll show you how to do it the other way. All you need to do is a half times 4/3. And really, you shouldn't even have to do that in the calculator, because that's just a simple multiplication of 1 times 4 and 2 times 3. The only thing is, if you do that, you will need to simplify your answer, because you'll get 4 over 6. All right, but I'll show you with the calculator. I do 1/2 times 4 over 3. And look at what we get. 2/3. And obviously this part just is separate, because we're only dealing with the numbers. Now look at that. We get the exact same answers. This one, personally, I think is easier. But at the end of the day, you don't even need to know where the root of the formula for the volume of a hemisphere comes from. You just need to know that obviously the formula for the volume of a hemisphere is 2/3 pi r cubed, because you may have to deal with it when it comes to calculating the volume of composite figures. So pause me right now and perhaps write that down in your books. Drumstick cone, I'm pretty sure I used that as my example in my total surface area video, but there you go, I'm going to reuse it and recycle it. Literally a drumstick cone. So imagine we've got the ice cream on top, but we don't, we've only got the cone. I've already gone ahead and written the formula for the volume of a cone. Two unknowns that we have here. The first being r, which you should know is your radius, and h, which is height. And you should also know that. So we are trying to find out how much space is inside this drumstick cone. Okay, the radius is 6, that's given to us, and our height is 13, and they're both in the same units, so we can substitute. Now remember, imaginary time sign when there are no gaps. So we've got v equals 1/3 times pi times the radius squared, which is 6, times the height, which is 13. And we put it in our calculator exactly how we see it. So we've got 1/3 times pi, the actual button, times 6 squared times 13. And the volume equals 490, and we're going to 2 decimal places as well. So if I cut that there, I only want 2 numbers after my decimal point. Our third number is 8, and 8 is greater than or equal to or greater than 5. So this 8 in front of it will now change to a 9. And centimeters cubed, because we have calculated volume. Okay? So it's just a matter of realizing which number belongs to which letter that you need to substitute in, substituting it in, and then putting it in your calculator. If you show working out like this, you're getting full marks. You can't just do it straight in your calculator, forget about all that, and write the answer straight away. You're not going to get full marks because you're not showing me that you know how to do the working out. So this is full marks. 3 lines, that's it. Okay? Lucky last, we're going to be finding the volume of a square-based pyramid. I'm sure in your younger years of health, maybe year 8, year 9 I'm guessing, probably year 8, but I'm not too sure, you would have learnt about the food pyramid, the healthy eating pyramid, where you've got your carbohydrates and your dairy and your fats and your fruit and vegetables. That is literally one of these, okay? A square-based pyramid. Or I know a lot of you guys like camping, so a tent, there's another thing you can think of, that's a square based pyramid. So how do we find the volume of one of these? Well, the volume equals 1/3 times the area times the height. Now, the height is obviously how tall this pyramid is. And the area refers to the area of the square. Now, it's a square-based pyramid. If it's called a square-based pyramid, this shape down here is always going to be a square. And you can see that it's a square because these dashed lines are in each one of its lengths. So that means that this is 5 centimeters, that's 5 centimeters, that's 5 centimeters, and that is 5 centimeters. So the capital A refers to the area of that. So basically to find the volume, the space inside this tent, you find the area of the square down the bottom and you times it by the height. So the area of a square is the same as length squared, so itself times itself. All right, so we can now change this formula to V equals 1/3 times L squared times the height. Okay, this is our L and that is our height. So remember, all I've done is I've said the area of a square is length squared. So now I've substituted the L squared into where the A is, because length squared equals the area of that. And now we just substitute. So V equals 1/3 times the length squared, which is 5. So 5 squared times the height, which is 18. So you put it in your calculator exactly how you see it. 1/3 times 5 squared times 18. That equals 150 centimeters cubed, because we calculated volume.